All right, folks, going to talk about the 11.6 notes, areas of regular polygons. So you found the areas of trapezoids, rhombuses, kites, rectangles, triangles, combinations of those shapes. But what about a pentagon? Our work here will also work for hexagons. It'll also work for octagons. All right, the formula I'm going to give you will work for any regular polygon. Okay? So in a regular polygon, we have all equal sides and all equal angles. When we talk about area, we have to know a few other things about the polygon. Every regular polygon has a center, like a circle has a center. It is the point equidistant to each vertex. Okay, and then here's a new word. It's called the apothem or apothem. You know, it's a segment. Okay, it's a segment that's perpendicular. So it's a perpendicular segment from the center of a regular polygon to the side. Polygon to a side. So I can draw, a lot of times the apothem is drawn in as a vertical segment. All right, it can be drawn up as long as it's perpendicular to the side. All right. Now, the area for a regular polygon is based on the area of a group of triangles, all right? If I put some extra segments to the vertices here, and I have an apothem length, it will say A is equal to apothem, and a side length, S is equal to side length. Now, if I were to find the area of this triangle, it'd be 1/2 times side length times apothem. But there would be, in the hexagon, 6 of these triangles. 2, 3, 4, 5, 6. And all of those triangles would have the area 1/2 times side length times apothem. But then I have the exact same number of triangles as I do the number of sides. All right? Here's what the formula is. A is equal to 1/2 ASN. All right, 1/2 the product of apothem, side length, and number of sides. So by multiplying by n, we're catching all the triangles that spin around this regular polygon. All right? Now, there is a short way to write the formula. Side length times number of sides is equal to the perimeter of the object. So we could say 1/2 the product of the apothem and perimeter. So we'd write that as A equals 1/2 AP. All right, P just replaces S and N. All right, let's take a look. Let's try a couple. All right, so decagon, that means there's 10 sides or 10 triangles. All right, that means n is equal to 10. All right, so here's the apothem, here's the side length. So let's do it. Area is equal to 1/2 times apothem, 5.7, times side length, 3.7, times 10 sides. Basically, what that 10 means is there'd be 10 little triangles inside that decagon. 10 triangles inside that decagon. I don't know if I have the ability to draw a decagon here. No, I'm not seeing decagon as a choice. All right. So let's finish the math here. This, you can multiply, what I did on my notes is I multiplied these 3 pieces together, 0.5 times 5.7 times 3.7, I got 10.545, and then I still have to multiply that by 10. Basically that 10.545 would be the area of one triangle, and then if I have 10 of those triangles, so the 105 10.45 centimeters squared. There it is. That's the area of that decagon. Octagon. Oh, I did see I had an octagon here. Let's bring it up. So that's this. All right, so this octagon. So the apothem, that'd be this distance from here to here. Perimeter is 80, so they've already done S times N. So octagon, N is equal to 8, all right? So they've already done 10 times 8, basically. 10 is each side. So area is equal to 1/2 times apothem times perimeter. So I'm using that version of the formula. So type that in, 0.5 times 12.1 times 80, you get 484 feet squared. All right, finally, a hexagon. They give us the perimeter again. So I'm going to use, N is equal to 6 here, but I've already done S times N. There's my apothem length. So this is a hexagon. Let's see if I got this hexagon shape. Yeah, there's a hexagon. So that's what they're doing here is this one. They're telling us this apothem is 10.4. So area is equal to 1/2 times apothem. And I've already got the perimeter, 72. And you get 374.4 square feet. So, yeah, that's going to catch the area of this whole thing, this whole hexagon. All right, that's it for this. That's it.